Howdy, it's Ms. Kosh, and we are looking at trig transformations today. This is a little more AP PreCal style than IB math, but I'm going to use it for both. So let's jump right in. We have these different variables that we can put in our equation. So I'm saying here that f is one of our 6 trig parent functions, and so we have an a value that will change our graph, a b, a c, and a d value. So it would look more like, I might say g of theta is equal to 4 sine of 2 times x plus pi over 6 minus 1, or something like that. Okay, so this is kind of that general format that we're looking at. And what I wanted to do is I want to break it apart and look at each letter with each shape. Okay, so on this first one, I start by doing the additive transformations, and then I used sine, cosecant, and tangent, and then I went ahead and used the same shape, but now I'm using cosine, secant, and cotangent with a different transformation, and then I'm breaking it apart by each letter, if that makes sense, but all 3 shapes. Anyway, hopefully this makes sense. I'm trying out something different and seeing if I like it. Okay, so the variables C and D are additive transformations, and so this first page deals with D. So here is our D value, this plus 2, and what that's going to do is it's going to take my parent function, which was provided here in red, and it's going to move everybody up 2. So what was at 0 goes to 2, so we have all of these zeros, and what was at 1, which is halfway between here, would then go up to 3. What was at -1 goes down to 2, or excuse me, what was at -1 when -1 plus 2 is equal to 1? I think this is here and then here. And so this is now our new curve. Okay, maybe not perfect, but I've done worse. And so we want to look at what changed between the apparent function and the new graph. And so the domain is still just negative infinity to positive infinity. My range has changed. The period is still 2 pi. The amplitude is still 1, because the amplitude is from the midline to the top. How high did we go? The asymptotes, there's still none. Okay, so always tell me that. And then the midline, what did it do? It went up. So this was a shift up 2. The midline went from, it used to be y equals 0, and now it went to y equals 2. Okay, the range was, it was -1 to +1, but then when I shifted up, it went from 1 to 3. Okay, so this D value will shift my entire graph up, and there we go. So the next one, with cosecant, my domain, well, now we're taking this graph and we're moving everybody down 2. So what was at +1 will go to -1. What was at -1 goes to -3. And so I'm moving all of these down. And so, but my asymptotes that weren't drawn in but are there didn't change. And so this is now opening up. This is now going down. I don't know why I picked random ones to graph. Okay, so what did that change? Did it change my domain? No, it's still, let's just remember what cosecant's domain is. It is still the set x such that x is not equal to pi k, where k is an element of the integers. For the sake of time in the future, I may not write out this entire thing. I might just focus in on this part right here. But technically, I should say all of that every time. Okay, so my range, what happened? Well, my range used to be, this is the one where we mind the gap. My range initially was -infinity to -1, and then we'd pick it up and go from 1 to infinity. But everything shifted down 2 units, so it's now -infinity to -3, and then we pick it up again and go from -1 to infinity. My period did not change, so it's still 2 pi. My amplitude, I don't have any amplitude. Amplitude tells you how high above the midline the wave goes. Well, these aren't waves. My asymptotes are still, maybe I should write stills, so we remember that it didn't change. That transformation did not change our asymptotes. I should write Kes, but I'm not going to. My midline, the inflection point, everything shifted down to y equals -2 is that midline, which is the d value. So notice how that moves that midline. And there we go. Anything else I want to say? No. Okay, so this next one, tangent of theta plus 1, that won't change our domain. So it's still a domain of, well, x is, oh, dang it, I already forgot. I caught it this afternoon or this morning. Everywhere I wrote x, I should have written theta. Okay, hang on. It's so that I'm just not in the habit of using theta. I'm sorry. Let's fix that really fast. There's one more right here. Okay, those should all be theta because they told us it was in terms of theta, and I apologize. It's a set theta such that theta is not equal to whatever, and it's still, asymptotes are still at theta equals pi k. And my domain, okay, see, I almost got away with it. Okay, my domain is still that theta is equal to, not equal to, pi over 2 plus pi k. I should write all of that out like we said a second ago, but I'm not going to. My range is still negative infinity to positive infinity. That will never change because any sorts of shifts won't restrict that range. The period is still pi. My amplitude, there's none. And my asymptotes are still theta equals pi over 2 plus pi k, where k is an element of the integers. The midline now, okay, so what actually happened? Well, this 0 shifted up. It's kind of over here, I guess. This 0 shifted up, and so then our graphs are just those inflection points. They're no longer zeros, but they're still inflection points, so you still want to show me their concavity on either side. And so the midline or the inflection points are when y is equal to 1. Okay. So far, so good? Well, let's keep going. The next thing is if I have cosine of theta minus pi over 4. Hopefully you recognize that this is going to take our graph and shift it to the right, pi over 4. Often I hear that called a phase shift of pi over 4. And so that's going to take every value that I care about, and it's going to shift it. Oh, that's funny. So pi over 4, so there, hopefully you see what I'm doing, and to the right, pi over 4. And so now our curve, be careful that you don't draw these too linear. So you definitely want to show the concavity as appropriate. And did that change my domain? Nope, it's still negative infinity to positive infinity. Did it change my range? Nope. It's still negative 1 to 1. Did it change my period? Nope. It's still 2 pi. The amplitude is still 1. There are still no asymptotes for a, this is cosine? Yes, a cosine curve. And my midline is still y equals 0. But what it did do is it changed my zeros. Okay, so one way we can think about that is we can take this equation, theta minus pi over 4, and set it equal to where the zeros used to be. Where were my zeros on the parent function? They were at pi over 2 plus pi k. And so I'm going to add pi over 4 and say theta is equal to 3 pi over 4 plus pi k. And so you'll notice here is at 3 pi over 4, and then when I add, this should be at 7 pi over 4, and sure enough it is. Subtract, that should be at negative pi over 4. So that's one way to verify that they're in the right place. So I took this part of the equation and set it equal to the zeros of the parent function. Okay? So that might be helpful. You could talk about the inflection points now being there or whatever, but okay. The next one, what is this one going to do? Well, you might notice this plus pi over 4 means we're going to go left. So we have left pi over 4, or they may call it a phase shift. I think I've seen a negative pi over 4 is how they would describe that. So there used to be an asymptote at pi over negative pi over 2, but now it's gone to the left. So there we now have an asymptote here. This minimum value right here is what I'm talking about, is now going to shift left pi over 4. This asymptote is shifting left. This is shifting left. Oh my, okay, so I'm kind of working off of the graph, and it's really nice this has everything labeled for us. It probably won't be labeled for you in the future. So let's talk about how we know all these things. And so this one is going to, oh, that looks terrible, is going to grow something like that. this one, anyway, is going to go something like that and something like this. Do you see how everything has shifted? What I would do is to find the asymptotes, I would take this equation here, this part of the equation, theta plus pi over 4, and I would set that equal to the parent functions. So this was, what parent function? This is secant, who has asymptotes at pi over 2 plus pi k. So now I solve for theta, and my new asymptotes are at pi over 4 plus pi k. Okay, let's come back and look. Did that match what I drew? I had an asymptote at pi over 4. I had an asymptote at 5 pi over 4. I had an asymptote at 9 pi over 4. That is a good sign. So my domain is going to be not that. So my domain will be theta is not equal to pi over 4 plus pi k. This is not the proper way to write domain, but we already talked about that. My range is still negative infinity to negative 1. Pick it up again from 1 to infinity. That shift did not change my range. My period is still 2 pi. I shifted, but it didn't change how far apart things are. I still have no amplitude. My asymptotes are what we wrote a minute ago. And my midline is still just y equals 0 is one way to think about it. And we can find these points here if I want to by saying, well, where was this point? And then, so I can take this theta plus pi over 4 and set it equal to where all those extrema were. So I had extrema at pi k. All right, let me verify. This one's at pi. That one right here is at 0. This one's at 2 pi. Okay, and so then they move to negative pi over 4 plus pi k. Let's see. This one is at negative pi over 4 right here. This one was at 3 pi over 4. This one was at 7 pi over 4, and we're good to go. So that might be helpful in finding those points. Let's look at cotangent. So what is this asking us to do? It's asking us to do a phase shift of pi over 3. So we're moving to the right pi over 3. Where are my new asymptotes? Well, cotangent originally had asymptotes at pi k. So if I do theta minus pi over 3 is equal to pi k, my new asymptotes are at pi over 3 plus pi k. And we can see that I would take the asymptote that used to be here, well, go away, and now move this pi over 3. Take the one that used to be at pi and move it pi over 3, and now we're here. And do I have more space? The one that used to be at pi would come to here at negative 2 pi over 3. The zeros, okay, so notice my 0 used to be at negative pi over 2, and I'm moving it pi over 3. Oh, that doesn't look right. Oh, I moved, so here's what I just did, I'm sorry. I looked at this value and thought, well, I need to move it, no, I looked at this value and thought I need to move it 2 units over, but I don't. The 0 is going to be halfway between these two asymptotes, so it's 1, 2, 3, 4, 5, 6, so I have to go 3 units away, which is 2 units away from here. Anyway, my brain mixed up the two, so I apologize. Anyway, go away. There's all the pink, it's gone. Okay, so this is where that point should be, and my graph is still doing something like this. Okay, and here's the other one doing ish. Okay, so the domain has changed to theta is not equal to pi over 3 plus pi k, where k is an element of integers. My range is still, maybe I'll say still, negative infinity to positive infinity. My period is still pi. My amplitude is, there's still no amplitude for a cotangent. And my asymptotes, they moved, and we wrote it down over here, to where theta is equal to pi over 3 plus pi k. The inflection points have now shifted, and what we did there is we said they started at pi over 2. So it was, I just forgot, theta minus pi over 3 was equal to pi over 2 plus pi k. And so when I add fractions, I have to get a common denominator. Pi over 2 becomes 3 pi over 6. Plus pi over 3 becomes 2 pi over 6. Do you have to show that work? No, obviously not. But we're going to have zeros at 5 pi over 6 plus pi k, where k is an element of the integers. And that's where this will be the x values of my inflection points. I probably won't ask you to write that expression, but you will have to graph it. So it might be tricky to see what's happening to those values, so you can always set this part in here equal to either the zeros or the asymptotes. I'm not sure how long this video is. I feel like I think I want to stop and make you come back for the next one. And then I think we'll have probably 3 videos for today. So, all right, like, subscribe, comment, all the things, and let me know how I can help you. Go practice. Oop, wrong button.